In last lecture, we have seen current measuring instrument. We have learned PMMC, permanent magnet moving coil, and in today's video, we are going to see measurement of voltage. In this video, we will see majorly DC potentiometer network and electronic voltmeter. First, let's see electrostatic moving wand type instrument. As name itself indicates, electrostatic moving wand type instrument. So in this instrument, it is clear that there is a electrostatic force, and also there are two plates. The one is fixed plate and the other one is moving plate. So what is in the instrument? There is one fixed plate and one moving plate. We apply independently voltage to the fixed plate, and due to that the electrostatic force is induced between fixed and moving plate. So it generates deflection, and a control spring is attached with the moving plate. So due to that control spring, the controlling or restoring torque is produced, which is responsible for deflection of the pointer on the calibrated scale, which shows the voltage. So this is working of electrostatic moving wire type instrument. Let's see in depth. The electrostatic moving wire type instrument operates on the principle of electrostatic attraction between two charged plates. Very basic. One, when high voltage, either AC or DC is applied, the electrostatic force is produced between the fixed plates and a movable wand. This force causes the wand to rotate, which turns more spindle connected to a pointer. A control spring provides necessary restoring torque to balance the electrostatic force. The pointer deflects over calibrated scale, and the amount of deflection is proportional to the square of applied voltage. So it is used for measurement of AC voltage. Due to its high input impedance and ability to measure very high voltage accurately, this instrument is commonly used in laboratories and testing setups. However, it is typically limited to voltage measurement and not suitable for current measurement or low voltage applications. Now, we will see that the electrostatic moving wand type instrument comprises key component essential for accurate high voltage measurement only. The fixed plate means electrodes are stationary conductors that produce electrostatic force when voltage is applied. Positions between them is a moving wand, a light-weighted metallic element that experiences electrostatic attraction and rotates it accordingly. This wand is attached to a spindle, which is supported by precision bearing to ensure smooth movement. The control spring provides the necessary restoring torque to oppose the electrostatic force, ensuring controlled deflection. A pointer connected to spindle moves over calibrated scale, typically non-linear. To indicate the measured voltage, the entire assembly is enclosed within protective casing, shield the instrument from external disturbances and physical damage. Here is the diagram of electrostatic moving wand type instrument. Here fixed plates are given and one moving wand is given. So we are applying voltage independently to the fixed plate, and electrostatic force is produced between fixed and moving plate, and due to that this is control spring, okay, which is responsible for restoring torque. And this is the pointer and this is calibrated scale. So this is simple. Now we will understand that it can be used for a AC measurement because deflection torque is directly proportional to the square of the voltage. Theta proportional to V square. Okay. And the instrument can respond to RMS value of the AC voltage. which is root mean square value. Okay. Now let us understand that when the applied voltage is too small, the electrostatic force between two plates becomes so weak. So generated EMF is little bit or null. So it's negligible. So it's not suitable for low voltages application. It is only used to measure high voltages. When highly accurate and traceable voltage standards are needed, transfer type electrostatic voltmeters are used. These are precision grid instruments often used in calibration laboratories to compare unknown voltages with standards. Now let's understand DC potentiometer network. So what is DC potentiometer network? We want to measure unknown EMF. That's suppose we want to measure unknown EMF and we take one known or reference EMF. We connect it with one resistive network like this, okay? And we have one sliding wire of length L. So this is also known as a jockey. So what we do, we uh, move this sliding wire on this potentiometer network. So when the standard cell EMF equals to unknown EMF and that time galvanometer shows 0. So we can get the unknown EMF. So this is basic principle. Now let's understand in detail. DC potentiometer is an electrical device used to measure unknown DC voltage by balancing them against a known voltage, allowing highly accurate voltage measurement without drawing current from voltage source. Okay, so here is nothing but we have to make the galvanometer 0 to obtain unknown EMF. Okay. The potentiometer compares the known EMF with the reference volt EMF. The null point is achieved when no current flows through the galvanometer. At this point, the potential difference across the length of the wire equals to EX. Using the length L at the null point and standard cell, the unknown voltage is calculated by unknown voltage proportional to the length, where K is the potentiometer gradient. A standard cell is a type of electrochemical cell that provides constant and known voltage and used as a reference voltage in electrical measurements, especially in potentiometers. It works on comparison principle. The unknown voltage is balanced against the voltage obtained from a known voltage source and a resistive network. A potentiometer wire acts as a voltage divider. When the potential drops across the wire segment matches the unknown voltage, the galvanometer shows 0 deflection. Okay, balance point. Constant voltage provides a steady voltage across potentiometer wire. Potentiometer wire is a uniform resistance wire, usually between 1 to 10 meters length. Sliding contact is also known as a jockey, moves along the wire to find balance. Galvanometer detects a 0 current, that is a null deflection. An unknown voltage source, it is the voltage to be measured. And standard or known voltage source used for calibration or reference. Okay. Now let us understand that for a low voltages, high sensitivity is needed, and for higher voltages, shorter wire length is preferred. Now, let's move to the uses of potentiometer. It's used in a calibration of voltmeters and emitters. Obviously, more accurate than direct voltmeter readings. It works on a null deflection method, which eliminates the power consumption in a unweak circuits. Now, we will see servo-operated automatic potentiometer system. It is nearly same as the DC potentiometer, but when what we were doing in a DC, we were moving that jockey wire on the potentiometer network manually to make galvanometer deflection null. But here the system is automated, and also here feedback control system is used by using servo motor. So let us understand. The servo potentiometer is a DC potentiometer system which is balancing is achieved automatically using the servo motor instead of manual adjustment. The known voltage is compared with the known reference voltage. The difference between Vx and Vr is detected by null detector. This error signal drives a servo motor to adjust the position of the sliding contact to the potentiometer. So this is a feedback to make the galvanometer zero. The motor moves until error is zero, where Vx is equal to Vr. Null condition is achieved. At the null, the value of reference voltage readout equal to voltage to be measured. So we can say this is a servo amplifier and this is the calibrated voltage scale, either analog or digital. And here is a servo motor and potentiometer. We apply an unknown EMF here and we can get the unknown EMFs by using servo-operated potentiometer system. At the null, the value of reference voltage is read out as a equal to voltage to be measured. A servo-operated automatic potential system is an advanced version of manual DC potentiometer designed to measure unknown EMF or voltage automatically. With a high accuracy and without human intervention using servo motor and feedback system. So human error is reduced. Human error and systematic error is also reduced in the system. So in this, we apply, we can see there is an unknown EMF and there is here a null detector. So output is given in a servo amplifier and where it is modified the error, and the error is the signal that sets the galvanometer to the null, so that through the feedback we can get the zero reading here and we get the unknown voltage to be measured. It is precise instrument used to measure unknown EMF by comparing with the known standard voltage using null deflection method when no current flow in the circuit at balance point, ensuring high accuracy than manually operated DC potentiometer. The key formula is voltage to be measured equal to the length of the potentiometer wire. Servo-operated automatic potentiometer enhances the system by incorporating null detector, servo amplifier, and servo motor that automatically adjust the potentiometer to achieve balance. The system uses feedback control to drive motor until voltage difference is zero, which point the unknown EMF is displayed directly. This allows fast, continuous, and accurate voltage measurement without manual intervention, making it suitable for measurement and laboratory automation. So let's discuss main components. Unknown EMF source is voltage to be measured. Reference potentiometer provides the comparable voltage. Null detector compares the unknown EMF with the reference and produces an error signal if there is a difference. Servo amplifier uses here is amplification of the error signal, and servo motor adjusts the potentiometer until null condition is reached. And the last voltage scale displays the voltage corresponding to the balance position. The unknown voltage is compared with the voltage from a slide wire potentiometer. If the two voltages are not equal, the null detector senses difference. This difference is known as an error and it is sent to the motor. The motor adjusts the potentiometer until the null detector is equals to 0. At the null point, the voltage across the potentiometer equals to EMF. The position of motor gives direct reading of the unknown voltage. So we can see the advantages: high precision voltage measurement, laboratory and standard equipments, automation in a calibration system, and use in some DCS. So in today's lecture, we have discussed event type, electrostatic DC measurement and DC potentiometer, and automatic servo type DC potentiometer. So all these are voltage measuring instrument used in a measurement. And also we have seen some advantages of this. In the next lecture, we will see more other instruments.